So introduce yourself first, Emin. I forgot it.
Yes, so I think I'm ready to go. So, my name is Emin Tatar. I'm from University of Groningen, and today I'm going to talk about experimenting with local large language models for grading of digital exams at University of Groningen. So on this project, I collaborated with Christian Morakiko, who's not here personally, but I hope he found some time to join the meeting online. So before also I start my presentation, I would like to thank the organizers for giving us the opportunity to present, because from the questions, yes, I think it was about time that we started discussing this issue. Yes. So now here is the outline of my talk. So I will quickly talk about how we ended up with this project, and then mostly we'll talk about the three experiments, or the experiments we did on three courses across different disciplines. Well, two of them are from computer science and one of them is from law. And then I'll finish my presentation with the lessons we've learned and some new questions that we ended up with. All right, so how did we get here? So at University of Groningen, we started this in September 2024, and the goal was to deploy a local large language model, not just for grading, but for three proofs of concepts. And we decided that one of these proof of concepts should be related to education, another one to research, and another one to the business. And these are basically the three pillars of any university out there. So then our team started laying out the common ground for all these three proof of concepts. We first selected the large language models that we want to deploy, and then the text embedding models, and we served them with VLLM. We also deployed an API to allow access to the technicians who are going to use these tools. We also deployed a local database, basically to put the text embeddings. Our team has also some hardware, and we in this project, so at the time, I think we have more now, but at the time we worked on these proof of concepts, we had these hardware, and these hardware were hosted on our university's HPC with the help of the HPC team. So we've collaborated also with our HPC team. So now specific information about the education proof of concept, the grading, in other words, proof of concept. We collaborated closely with the education domain at Center for Information Technologies. They organized focus groups, and we were invited, and we had the chance to listen to the lecturers, what they really want out of this grading process. And we learned that they don't only want the score, they also want the feedback for the student, but also for themselves. So they want an explanation, okay, why this student is getting this feedback and this score. So then also on the technical side, we decided to use a very general and basic language model to do the grading, because I'd like to really test. We don't want to be dependent on the large language model. We like to develop a system that is good, and it can only get better with a stronger model. So we adopted something very small and basic, and of course open source. Then we started networking, again with the help of the education domain. We started talking to the lecturers and asked them if they are interested in joining our proof of concept, our experiments. So ARW, it has a long Dutch name, which I'm not you will see its full name, but I cannot pronounce it here. So FDS, that's fundamentals of distributed systems, and from computer science. And probability and statistics is also from computer science. Well, for probability and statistics, Christian and I teach that course as well. So we are technicians, but also lecturers. So at computer science, so it was just natural, like any scientist, to test the cure on ourselves. Now let's dig deep into the experiments. The first one, FDS, this is the data from June 2024. During that time, 99 students took the exam, and there were 20 questions, open-ended questions, 40 out of 40 points. And the exam was organized in problems which are made of sub-questions. And the problems had its own context as a text, but also as an image. Like you see here. So, and the sub-questions were depending on this text and the image. And it had, I think this part is still a text, not an image, but the sub-questions could have also had images. And the response created by the instructor had the points for that question broken down into steps. So, and this is, we run 2 experiments on this exam setup. In the first experiment, we provided LLM the problem with sub-questions, with the instructor's model answer to all these sub-questions, and with students' responses to all those sub-questions. So points per step were also in the instructor's model answer, and we asked LLM to return score feedback for student and the instructor. And in the second experiment, we provided LLM the entire exam. So we didn't bother with problem by problem. We sent everything together.
Complete exams, just
complete exam
with 40 questions in it.
Well, only the written response ones.
Okay, the written response one. All right.
Yeah. So with all answers to those written response ones, and also students' answers to all these questions. And we asked again LLM to respond question by question. But in one go, basically. Because usually people expect from these systems press and go type of attitude. So, yeah. Okay, so here are the results. You see visual and numeric results all together. Let's talk about the visual results. Points represent students, and red line represents perfect agreement between human assigned grade and LLM assigned grade. Of course, you want those blue dots to be on the line or close to the line. That's the goal. And that's not the case. Well, that's also the expectation. The difference between experiment 1 and 2 is that there is a clear deviation from the red line in the first experiment in favor of a human grader. So you have on the horizontal the human grader, on the vertical the LLM grader. And we see that deviation corrected in the second experiment at the expense of a wider variance. So is that we don't think this is good, but when we look at these both pictures, we see that LLM is going in the right direction. So at least it is capturing the line, not completely aligned. Some standard mistakes, errors or biases that we don't know of. We want to change experiment 1 into experiment 2, align these points perfectly with the line, but also not create too much of a variance. So for probability and statistics, we did exact same experiments, so problem by problem. and also entire exam. But in this case, we had 102 students, and this data is from November, December 2024. The exam is also designed in a similar way, problems with sub-questions. The difference was in the questions itself, not so much in the organization. Here we have also R code. So students were also typed code in this exam. And let's look at the results. So we still see a similar behavior in the experiment one, where the questions are sent problem by problem. We have a clear deviation in favor of the human grader. It's less than the other course, but it's still there. When we send the entire exam, this is corrected, but this time we are shifting towards the in favor of LLM. So points are slightly above the red line. So it's a huge swing again, which we don't like. But still, it goes. It follows the lines.
And what in terms of correlation or how to call it reliability thing? How big is the correlation between the two observations?
So we haven't looked at the correlations, but we've looked at the variances.
Yeah, variances. Yeah.
So this is the observed variance. So in the in the first experiment, the variance, which is this, is less than the original one, and in the second experiment, we overshoot the variance. Mm-hmm. So that's why it says these are not very reliable. So it swings largely around the original variable, around the original variance.
So if I look a little bit through my eyelashes, then I would say it would be like 0.8 or something, which is in terms of a regular exam reliability, it's quite high actually, to be honest. So it's not perfect, of course.
Yes.
Nowadays it's also not perfect. So it's not really worse. It's not like a round cloud of dots. Yes. It's like a...
Yes, that's true. Maybe these are acceptable. And if we had seen only the LLM assigned grades, would we accept them? Would students have accepted them, or instructors accepted them? Yeah, we don't know, but maybe.
We kind of have sometimes the idea that AI gets sloppy when being asked too much. So we also remember that we did an experiment where we looked at assignments. Can you check if a word is in the text? And then it kind of really does its best at the first order of the words, and then of the text, and then afterwards, like, yeah, whatever, right? So it's like a, I cannot humanize it, but like the concentration goes down. So how would you, do you have any idea how this variation is?
No. Honestly, we don't know why there is a big swing. But one reason could be the following, especially for the FTS case, and this is something that I forgot. We didn't send the images.
Okay.
So the images were missing, and sometimes the questions were asked in a way that, so look at the image and answer this question, but image was missing from LLM. Mm-hmm. So maybe that can explain this big deviation. In the case of probability and statistics, not every question was open-ended question, so we had to remove them from the exam. So by removing that, are we losing the context? So if the entire exam is not open-ended exam and you had to remove certain questions,
yeah, do you remove context?
Do you remove context? So
level that, yeah, okay.
So those are the things that we believe is happening right now.
All right.
We have Wilma saying 0.8 for reliability between assessors is something else than 0.8 reliability for an exam. So that is just a mention. And then we have somebody saying shouting helps AI to concentrate. So that's also a very good thing. And then we also have some questions about statistics. So we might want to keep that one for
later.
Yeah.
Okay. Yes, so I think in my coming up experiments, I'm going to force LLM to concentrate. So that's yeah, that's I haven't put it in that words, but it's a good way to put it. So our last experiment is on this course. Now you see its full name, ARW, and it's given again. Its data is from November 2024. This exam was taken by 617 students. The entire exam was made of written response questions, and there were 14 of them. The total exam was out of 80 points. So this exam was based on a textbook, and also the last 4 questions were based on a real case, and students had access to that case file during the exam. So you see a sample question and a sample instructor's answer. They are all in text. Well, that's a law exam. Also, if you notice, this is in Dutch language, and we haven't changed our model for this course. So we still kept Llama 3.1. And also, if you notice in the model answer, you have the point breakdowns. And using those breakdowns, we run 2 different sets of experiments. I call them holistic and analytic. And let's look at those ones. So holistic experiments are similar to the experiment 1 of the FDS and probability and statistics, which means we submitted question by question to LLM the exam questions. We also submitted the student response and instructor response, so exactly like the other courses. But this exam is also based on a textbook and a case file. So we said we have to also use this information. And so in the first experiment, we used the relevant sections from the textbook, and we also provided those sections in our LLM input. So relevant to the question. So not to the model answer, but to the question. And to embed the textbook, we've used, again, a small text embedding model. And in the second experiment, we included also the case file. So especially for those last 4 questions, we included in the prompt relevant sections from the case file. Okay, so here are the results of these 3 experiments. Again, very clear deviation from the agreement line, but this time in favor of the large language model and also on the lower end of the grades. So it's not at the tip, but it's at the beginning. So but still good news is that it's somehow following the line. Deviation is stronger in this case. And if you look close enough, the best one is in fact experiment 0. So the best one is when we don't give this relevant context from the text or the case file. And we explain this situation as follows. I think the graders followed closely the grading schema. So they didn't look at the textbook, and this is 600 for students, 14 questions, a lot of graders. So most probably they just stick to the grading schema. So now here is how we decided to force LLM to focus more. So I call this experiment step-by-step experiment, or that's number 4. 3 failed totally, so 0, 1, 2, and 4. That's how we go. we provided LLM in this case, so question, student response, instructor response, but also step. So we ask specifically, rate this step. You might say why you have the step and the instructor response, so both of them, because step is part of the response. It's because we didn't want LLM to lose the context. So it knows where that step is in the whole response. And we didn't ask LLM to return a score. We want the LLM to return a scale. So, and so to be more clear, this is, if you remember the model answer from the earlier slide where there were subpoints. So exactly at those subpoints, we broke down the answer into steps, we labeled them, and then we kept the values to each one of these steps. And then once the rate is returned by the response, we did the math to calculate the score, basically. And we tested with 4 scale types because in this setup, how do you choose the right scale? And the responses of those 4 scales. So it's a little bit small. And the definitions of the scales are here. So the 2 scale it's basically binary, successful or unsuccessful, and all the others are we just added intermediate steps between successful and unsuccessful. So these are the exact wordings that we have used to explain the levels to the large language model. And if you look at it, again, this deviation is gone from the agreement line, and the best ones are returned by 2 and 7. So the red line goes really loud. And in the case of 3-level and 5-level experiments, points are slightly above the line, so which is favoring the LLM grader over the human grader. I'm going to throw you more numbers. So in the next slide. So this is mean absolute error based on the total score and per question. Experiment 4 with 2-level scaling, 3-level scaling, and so on. So this L number refers to the scales. According to this, there is no clear indication of which model is better. But one thing that you can notice is that the error on the total is way less than at the question level. So we got this question: what's the right way to assess these tools? Should I look at the total, or should I look at the question level? Because clearly we are missing the questions. The error, basically these are percentages. So at the question level, the errors that we see are not less than 10%, but overall we get 6% or less than 10%. So this means scoring-wise we match, but maybe we are losing the objective of the exam because objectives are hidden in the questions. Okay, instead of the error, we looked at the exact number of exact matches. So, and L2 scaling or LT3 scaling gave us the highest number of exact matches at the question level. So in this exam, so the last column here shows the percentage. So more than 1/4 of the exam is corrected or graded correctly without any errors. And this is the variance table. And our L2 model matched exactly, or is very close to the variance of the human grader.
Before you continue, because you extend a little bit your talk,
okay,
which is not too bad because we've built in a little bit of leeway, but maybe.
Okay. So this is actually my last slide. So lessons learned and some questions. So we believe the exam design and also the design of the model answer is very crucial. And if you pay close attention to that, there is no need for including the documents of that course. We think that based on these clouds, point clouds, the feedback generated by the LLM will be accepted. But grade is a sensitive issue. You've talked about that. But if we go with the scaling of the objectives, the steps, this makes the process explainable. You can say to the student, you miss this point. So I can give exactly the step number that you have missed. So it's a very explainable solution. We believe that we need to run more experiments, but not blindly. We think that we have to first design a methodology. Again, these are discussed already, how to keep the human in the loop. Start with the LLM, have the second loop by the instructor, and then continue with the LLM later, repeat that loop or once or twice. So, and some questions that we have raised, can we identify human inconsistencies? So quickly, you see those kind of effects. We believe that these are inconsistencies because in one grading scheme, you have a huge variance. In the other one, there's no variance. Mm-hmm. So why is that? Why these two types of grading don't agree? So those horizontal or vertical lines for us is a locations where you really need to look closer. What's the best metric to assess these outcomes, like I said? And finally, do we really need LLMs for scoring? We need it for feedbacks, but for scoring, if we really break down our rubrics, can we go with the tools of topic modeling? And maybe we don't need to send those big tokens to LLMs, which cost a lot of money. We can get, we can do a topic modeling. Your response is close to this, let's say, step. And then use those steps to generate a feedback. So your input to LLM is extremely small, your costs are extremely small, and well, this can be also a solution for using less LLMs, okay, maybe. And I'd like to finish my talk with the special thanks to these instructors who joined our experiments from Faculty of Law and Bernoulli Institute, and also my thanks to everyone here and also online.